All right, you ready for a thorough exponent review? The first thing we'll want to do is we'll want to get rid of these parentheses by distributing this squared into each and every element of the numerator. So let's take a look at how that goes. The first place we distribute the squared is to the 4, and 4 squared is 16. The next place we distribute the squared is x to the negative 3 squared. Now remember, when you raise to a power, you multiply the exponents. So x to the negative 3 to the 2 is x to the negative 3 times 2, which is x to the negative 6. Next up, y squared squared raised to a power, multiply y to the 2 times 2, or y to the 4. And finally, z to the 1 to the 2, or just z squared. And now we'll copy our denominator in there. So now we can take each bit of this individually. The first thing I see is 16 divided by 8, which will leave a 1 on the bottom and a 2 on the top. And we don't need to write that 1 on the bottom. Okay, next I see x to the negative 6 on top, and there's no x on the bottom. A negative exponent means 1 over the positive version of that exponent, which means this fraction times 1 over x to the 6th, which just puts our x to the 6th into the bottom there. In the future, we can use the hack that if it's negative on the top, it's positive on the bottom. And if it's negative on the bottom, like this y to the negative 4, then that would be the same as positive on the top, y to the 4th on the top. And now when we have y to the 4th times y to the 4th, when we are multiplying with exponents of like bases, we add their exponents. So y to the 4th times y to the 4th becomes y to the 4 plus 4, or y to the 8. And remember, the base does not change, right? So y to the 4 times y to the 4, that doesn't turn into a 2y or anything. It stays just y. Now our final piece, z to the 2nd divided by z to the 3rd. We can do this one of two ways. When we divide exponents, we subtract their exponents. So we could turn that into z to the 2 minus 3 on top, which becomes z to the negative 1 on top, which becomes just z to the 1 on the bottom. Now, the other thing we could have done there is we could have subtracted in the other direction and made that 1 over z to the 3 minus 2 on the bottom, which is just 1 over z on the bottom. So that would be the more direct way to get there. But that right there is our simplification of this first problem. Next problem, we have a fractional exponent. Remember, with a fractional exponent, the numerator is the power of the exponent. The denominator is the power of the root. But before we apply that, we're going to see if there's any internal simplification we can do. 27 and 5 do not share any common factors, but x to the 7th divided by x to the 3rd, those are the same base, so we can apply that when you divide, you subtract the exponents. X to the 7th divided by x to the 3rd becomes x to the 7 minus 3, or x to the 4, all of that raised to the 1/3. So now we apply the cube root to top and bottom. All right, let's work with our numerator first. So we can separate this again. Well, the cube root of 27, that's asking what times itself 3 times is 27. That has an integer answer, that's 3. To resolve the cube root of x to the 4th, we'll want to separate that x to the 4th into x times itself 4 times. And then we'll remember that x times x times x, that's x to the 3rd. The 3rd root of x to the 3rd, that's why 3 on the inside is 1 on the outside, because the cube root of x to the 3rd is x. And then we have left inside an x. Now, we know we're not allowed to have roots in the denominator of a fraction. So how do we rationalize a cube root? Well, we need to multiply top and bottom by what will make this a perfect cube. So we have 1 5 under a cube root. We need to multiply it by 2 more 5s under a cube root. And if this is the first time you're seeing this technique, then go check out this video, which more slowly takes you through how you rationalize the denominator of a cube root. But continuing, if we multiply the bottom here, the cube root of 5 times the cube root of 5 times 5, that gives us the cube root of 5 times 5 times 5, which is the cube root of 5 cubed. And that's that concept again of 3 on the inside, give us 1 on the outside. And so we have turned our denominator into just 5. Now up top, we need to combine everything that's under a cube root. And so that turns into, and that is the fully resolved simplified version of this. So that was a quick review of all the different elements we've looked at so far with exponent work. If you want to take a look at any of them in a more in-depth way, take a look at these videos on fractional exponents, on negative exponents, on MADSPM and how to use it. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.